Welcome to another episode of the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is Daniel Whitneck. He's actually been on the podcast before. So Daniel is a data scientist with SIL International, and he's the host of an AI podcast called Practical AI. First time Daniel was on the podcast, he gave us a fantastic introduction to artificial intelligence. And today we're talking about ChatGPT, and more generally about large language models and what it means for us in our work. Hey Daniel, welcome back to the podcast. Yes, you've been here before. Last time you gave the audience an excellent introduction into artificial intelligence, and today we're talking about ChatGPT, which is also, I guess we could argue back and forth whether that's artificial intelligence or not. Maybe some of that will come out during this conversation.
Yeah, well, certainly everyone's talking about it.
Yeah,
So,
exactly. But before we dive in the deep end, why don't you just give us a brief introduction for those who didn't listen to the last episode? Who are you? What do you do?
yeah, my name's Daniel Whitneck. So I'm a data scientist with SIL International, which is an international NGO that does language-related work around the world, literacy, education, translation, and even some mapping of language populations around the world. I also am building a product called Prediction Guard, which is a tool for those integrating AI into their applications. And I'm the co host of another podcast, which is focused on AI each week. It's called Practical AI.
And this is how I found you, through that podcast. And I really appreciate you
Yeah.
taking the time to join me again today. Thanks for that. Chat GPT 4. Let's start right there. What is it?
Yeah. Good question. So I think most people have seen this sort of basic chat interface where you can ask a cool question. The one I asked yesterday was, give me a set of emojis that describes the state of hacking on demos while falling behind on email, which was my state yesterday throughout the day. And it gave me that set of emojis. So these systems, so that's like the front facing side of things that probably people are rather familiar with. On the back end, what these systems do is they take that input or that query from a user, which is just natural language text, and they try to predict a completion of that or generated text or generated formatted text, maybe code or structure, some sort of structure that completes what that prompt would be. So I asked for a set of emojis that describes blah blah blah. Then it predicts what should essentially come next in the sequence of characters that were put in. So these are mostly what are called causal based language models, which all that means, it's a fancy term for saying it's predicting what's coming next in the sequence of words or tokens or characters based on what came prior in the sequence of code or tokens or characters or words.
And just to be clear, so we've got this idea of prediction here based on what happened in the past. Are we talking about time-based past, or past as in the sequence of characters that I put in?
Yeah, past is based in the as in the sequence. Yeah. So if I have, my sequence of words, what is a set of emojis that blah blah blah, it's looking at each of those either words or subwords or characters in a sequence of those and then predicting kind of the ones that come next, which is, you can kind of almost see this in how they visualize this in the completion of like the way that text streams into the interface. Although I'm not exactly sure how they implement that streaming, but I think that that's meant to give that idea of how this completion is happening.
Okay, so this is what it's doing. It's creating a prediction based on the past, no, based on the sequence of data that it's getting from us. It's using that as a base and then moving forward from there. How is it moving forward? How is it making these predictions about what might be next?
Yeah, good question. There's actually these type of language models have been around for some time. A lot of people now know about ChatGPT, but people might have previously heard about things like GPT-3 or GPT-2 or BERT or other models in the past that are these sort of what's generally called large language models. And the way that these are trained or how they're created and how they work is that under the hood is a neural network, which you can kind of just think of a neural network like a series of data transformations. I know that's a very simple way of putting it, but there's no sort of like fairy dust or magic happening here. It's really a set of data transformations where you put in one set of data, usually a vector of numbers, and that's transformed through a series of functions, many of them that are parameterized. So some people hear about like the parameters of these models, like 60 billion or 200 billion or whatever. Those are the parameters of these transformations. And then out the other end comes another sequence of usually numbers, which is maybe decoded into text or something. But the way that people find these parameters for the data transformation. So the question is, okay, I want to put in text represented as numbers and get out other text represented as numbers. How do I find all of those parameters to create that transformation that I want to happen? And the way that happens is by essentially trial and error. So you have a whole bunch of example text, and your job is to maybe predict the next word in the sequence of text. And so you create all these examples of here's a sequence of words, here's the next word, here's a sequence of words, here's the next word, here's a sequence of words, here's the next word. And then you use those examples to parameterize or to fit the parameters of that model. That sounds rather simple or non magical, which it is. It's just the fact that this is happening on an extremely large scale that makes these models very powerful. So they're essentially training the model using examples of all of the internet that they can scrape, right? Or all of books that they can gather and that sort of thing. So there's a huge amount of data that goes into that. And then in addition to that, one of the interesting things, which we can talk a little bit more about if you'd like, is how they tied in an element of human feedback into the training of models that are used in ChatGPT and similar systems. That's kind of how these models under the hood work and how they're created and what OpenAI did to create these models.
Thank you very much for that. Firstly, I'd like to say that reply to your comment there. I think you said it twice. So it's not magical. I I kind of think magic is in the eye of the beholder.
Yeah.
People say beauty is in the eye of the beholder. Well, magical stuff for me is the same way, and I'm pretty sure Arthur C. Clarke would agree with me here. When I listened to you explaining how this works, it sounded like it was building predictions on top of predictions. It sounded like it's prompting itself at some point. Like at some point, we move away from that initial piece of data, that initial sequence, and it just starts building on top of itself. The thing I think is amazing about this is that it doesn't drift. When you think about how trying to predict a location of something through time using dead reckoning without any sort of artificial stimulus, we get this drift. It starts to head off. I don't see this with ChatGPT.
Yeah, it's interesting over time. This is one thing that has changed with language models is the sort of amount of context that they're able to take in, and that somewhat is tied into the size of the models and the size of the inputs that they can take. So I believe I always get my numbers mixed up, so don't. I could be wrong about this, but a lot of the language models now, either from OpenAI or Cohere, these other offerings, a lot of times you'll see a context of around like 2,000 characters or something like that, that it's taking into account as it predicts that sort of next bit of text. Whereas I think the latest models like GPT 3.5, GPT 4, they increase that quite by like double or more. So like 4,000 or more characters. So there's a lot of context that it's looking at to make that next prediction, which means that, again, if you think about this like a data transformation under the hood, that model or that parameterized data transformation has to be bigger and bigger to account for that more and more context, which means you need more and more data to train this on. And that's why most of the time, these large language models, you see them kind of offered by maybe tech companies with a huge amount of funding or big tech companies. And it's because there is a lot of effort into kind of getting these data sets together and training a model that's that big.
So I think you mentioned this before. It was something about the way they've used humans or integrated humans in the loop to help train this to make it better, which makes me think that it's not enough just to have a lot of data, like you're talking about, like a huge model and more data. It sounds like it's not enough to have that. We need some sort of guidance happening here, preferably by by humans. Can you talk us through this idea of integrating humans into the training loop to make things better?
Yeah, and I think that the reason why this is so important is because of the very fact that these models, even though they can seem to be almost sentient in the sense of like the humanness of the text that they generate, at the end of the day, they're pattern matchers, right? They're extremely complicated and advanced pattern matchers, but they're creating text output that is what they think, and I shouldn't even use that terminology, they think it's sort of anthropomorphizing what's going on. It's really that like the output probabilities are such that like that system is making probable combinations of text that it's seen before. And this, without human input, can produce some rather disturbing results, which is probably maybe some people have seen some of this on Twitter or wherever, but there's been certain models, like Galactica is one example that was trained on a huge amount of scientific literature to produce output that kind of looks like academic papers. And you could ask certain things like, how many giraffes have visited the moon, and it would give you this very scientific sounding explanation of, oh, there's been three giraffes that have visited the moon, and the Russians sent one up, and this, and it will even give citations and that sort of thing. And obviously, that's not how a human would prefer the model to answer. It's how it understands the text that it's seen. Like, this would be the probable way to answer this. And that can be really bad. I think even in that example, like the model was like outputting text, giving like the benefits of eating glass and other things, which can be quite disturbing. So there needs to be this kind of additional element in many cases for systems that are kind of prompted dialogue systems that interact with humans. And the way that ChatGPT integrated this is using a methodology called reinforcement learning from human feedback, which, similar to the other things related to ChatGPT, it's not a new concept, but they did apply it both at a scale that maybe hasn't been seen before and with models that are more powerful that have been seen before. And the idea is that you have that language model, like we've been talking about, which is trained on a bunch of text, but you also gather this data set of human preference of, maybe how a human would respond to this answer versus how the model would. And if a human prefers a certain response more than other responses. So it's essentially like rating data or preference data. And then you use that preference data to train a second model, which you kind of pair with the language model that you're training in a loop. And that kind of helps fine tune the big language model to the human preferences that you've gathered. And that's, I think, what maybe stunned a lot of people when they saw ChatGPT is prior to ChatGPT, a lot of the public models that you would see kind of like a really good text that comes out, but it's kind of weird, right? Like it's not a typical human would say like, oh, well, that's like really interesting and compelling, but it's not exactly like how I would prefer this to sound or prefer it to be answered. Whereas with ChatGPT, you sort of immediately saw, oh, this is exactly how I wanted it to answer, like very much so. And actually, maybe even more so than I expected. I think a lot of that is due to this training strategy related to the human feedback.
But when you were talking there, there's a few things that really sort of stuck out for me. It was, and it almost sounded contradictory. So you said things like pattern matching, predictability, and for me, in my mind, I'm thinking, oh, sameness, boring. I know, certainty, and it doesn't rhyme with the creativity that we're seeing from this model, for example. So I want to talk a little bit about that, and I think maybe we should do that in the context of something called temperature. Can you help us understand temperature, please, and how this might lead to creativity?
Yeah, yeah. I've been thinking about this a lot actually because I do think that this is not shifted my mindset in terms of like what the models are doing, but how to think about our usage of them, which we can talk about later. But yeah, there's this element of creativity that happens. So like when you could imagine a sequence of words, right? And you're trying to predict the next word in the sequence. There's likely going to be a most probable prediction of that next word in the sequence. And if you always choose that most probable next word, then you might get really good text out. So it might still be really good text, but you'd kind of, whenever you prompted it, you'd get the same thing, right? So in these systems, developers have built in this concept of temperature, which you'll see this across a number of different language models, which is kind of a control parameter or a hyperparameter that controls how much, like you use the word creativity, but it's really how often like the model chooses kind of that strict next probable thing in the sequence versus maybe the third most or the fifth most or something like that. Because again, human language, if you think about human language, we rephrase things and say things differently all the time. And different people have different styles of saying things. And it doesn't mean that like we can't understand each other, right? It just means that there's a lot of variability in how we express things. So they've tried to build this variability in with this element of temperature. Now, where this can go a little bit awry is if you set that too high and you're expecting kind of reliable, robust, consistent results, you may not get them, right? So there's an element here where humans are still kind of configuring and figuring out how to use the parameters of these models, especially in the context of like enterprise usage, where maybe I don't want as much variability in terms of answering user questions out of a knowledge base or something. Or maybe I don't want that much variability in terms of how to visualize this geospatial data in a certain way. Or maybe I do want that sort of variability. Like people visualize geospatial data in all sorts of ways, right? And if I'm generating some helps in how to do that, maybe I do want some creativity, which I think is really cool in how people are using this, not as a replacement to what their day-to-day work is, but almost as a muse or a way to infuse further creativity where they may have writer's block or they might just want a new way to do something and they ask for that new way and kind of get that kind of sudden infusion of creativity.
And I think too that sometimes it's not it's one thing to have a clear sort of vision in your mind. Yes, I want to go that way. But it's also helpful to say, no, I don't want that. You showed me five things there. No thanks.
Right.
And it confirms the fact that, okay, well, that's not the way. But for me, it's kind of this narrowing down of the possibilities. I just want one to work on at the moment. Thanks. Which way is to go? And I think, positive or negative feedback would be helpful for someone like me anyway.
Right.
Thank you for the explanation of temperature. I appreciate that. How does that tie in with the idea of hallucinations?
Interesting topic and and a difficult one at the time. So, if you think about these models and how I've described them, what's happening under the hood is there is a model, you put in data, that data is transformed to predict the next things in the sequence. All of that's contained within the sort of parameters of the model, which were parameterized based on the data that it's seen in the past, right? So if you ask about something that is maybe not that well represented in the data, or maybe there are conflicting answers in the data, or the sort of logic is not that clear, the model has no problem in outputting coherent text that responds to your prompt. It might just be like completely factually incorrect, right? It was kind of the thing that I mentioned with the giraffes, right? Like I can ask about giraffes on the moon and it will tell me about giraffes on the moon. There's no connection to reality there. Like this model is not, there's no intent, there's no understanding under the hood. Like it's computing a sequence of tokens out, right? Or characters or words out. So this is how you get these sort of hallucinations that people are calling them out, which is really, really coherent sounding text, but that's completely factually incorrect, right? And that could happen more as you sort of play with this temperature parameter. But it might even happen if the temperature parameter is set fairly low and you get fairly predictable output. Because again, if you prompt it in a certain way that is kind of somehow complicated in the data that it's seen, or maybe misrepresented or not represented in the data that it's seen, it will just make something up, right? In terms of the output. So this is that idea of hallucination, and how people I think are really recommending developers especially think about using these models is by pairing one of these models in a way that has some type of what people are calling grounding, meaning you have some external knowledge that you're infusing into the prompts of how you're prompting these models. So, for example, I could have a knowledge base or a set of documentation, something like that. And I could ask the model, what is this or what is that? Or could you explain this concept to me? And if I first search the knowledge base using, even something dumb like a full text search, or maybe something more advanced like a neural search of that database, and get something that humans have written in documentation that's factually correct, and then I just insert that into my prompt and say, hey, could you answer this question based on this context? Then I've grounded the output of the model in reality rather than just assuming that the model will respond well based on the data that was exposed to the model during training.
So now I think we have an okay understanding of this. At least I hope that listeners have a high level understanding of what Chat GPT is, what it does. We've talked about a few of the bigger concepts around temperature hallucinations. We know now that it's a causal language model. You've walked us through how humans have been involved in the loop to help train it, to help understand what is preferred and not preferred in terms of output, which I really appreciate. Is there anything about this? It's caused quite a stir in, the wider internet. Was there anything about this that is surprising to you? Or knowing what you know with your background, were you like, "Of course, somebody was gonna make this one day. Of course, these things would be possible."
There's a few things that are probably surprising. I think the things that are surprising to me as an AI practitioner aren't the models that were used or the methodologies that were used, which, like I said, were have existed and have been used in other contexts and are continuing to be used by other entities and with success and in certain domains and all of that. But I think that what is surprising is the way that OpenAI executed both the sort of like demo interface and how it presented it, the simplicity around that paired with kind of some of the limitations that they talked about when you get into the interface. I think we just saw like the power of getting this technology in front of the general public in a simple interface that they could immediately understand and start interacting with. So I mean, that's a general concept in development too. I think demos and prototypes that can be compelling. You just learn so much from those, and they're so powerful. So that I think it was surprising to see how quickly that was adopted. But the other thing that has been constantly on my mind, which is maybe a little bit more weighty than that, is the fact that, and this was a point made by Chris Albin, at least that I saw on Twitter, who's a data scientist or leading the data science and machine learning at Wikimedia, that we always thought that machine learning or AI models would be logical but lack creativity. But actually, the reality of where we're at is the total exact opposite of that. So, if we think about what computers can do well now in terms of AI and what they can't do well, and what humans can do well, and what computers can't do well, computers actually are really good at creativity. They can generate images from text, and they can generate this coherent, amazing, like I can write a new rap song by Eminem about, me and my AI podcast or whatever, where they have a lot of creativity. Often they lack logic. And there's this need for humans to post edit in terms of both factual consistency and grounding in reality and all of these things. So it's interesting that that sort of sci-fi vision of AI is logical but not creative is actually the complete opposite of the reality that we find ourselves in, which is AI is creative but not logical.
That is really interesting. I can see it in terms of, create this text. You said, write a song for me in the voice of Eminem about me and my AI podcast. We can see this. Here's the text. Please create an image based off that. Give me 5 different variations of it, that kind of thing. But we also see this solving coding problems, which I understand there's a creative element, writing code, writing great code. I totally get that. But it also seems to me that this is perhaps even more predictable than the human language. And actually what we want there is we want logic. I want this to work. Can you talk a little bit about maybe some of the challenges around using this to write code, perhaps where we are at today and perhaps what a possible future looks like?
Yeah, this is a really interesting subject, which even before ChatGPT came out, I was already using GitHub's Copilot to augment my code writing in my VS Code editor. And so I think this is a really powerful place where AI can kind of serve as a digital pair programming twin or an assistant or something like that in our own code writing. As you mentioned, code is has some similarities with language, but in many ways it's a bit more predictable. Maybe depending on what code you're writing, something like Go or something like that that's statically compiled and has one way to have formatting done is maybe a little bit more predictable than JavaScript and the million different frameworks that go along with it. But I think in general, code is a bit more structured and predictable. And there's certain things that happen in code that, like, if you think about how many times people have implemented something in code to pull X thing for Y user out of a SQL database, right? That's happened, however many millions of times over over the years. And so if you train a model on that, that's something that a model will be able to do without, any issue. Is I can go into my code and say, or I can go into Chat GPT and say, could you write me a function that pulls this data out of a SQL database that's Postgres and returns this data. It will probably do that almost perfectly every single time. Now, here there is this element still of like hallucination that happens where like it does it mostly perfect, but there's still a need for the human to kind of like look at that and post edit it. So like right before this call I was in Chat GPT and I said, so I just got a bunch of GeoJSON files from one of my colleagues that are just the GeoJSON files. And I'm admittedly not a visualizer of maps or a mapping person. So I just asked, hey, write some D3 JavaScript code to visualize this GeoJSON file. And, it output the code, but it has some file in there that's not the file I want to visualize, right? Like it has some file that's your GeoJSON file.json. Well, if I take that and I just copy paste it in, it's not going to work, right? Because I don't have that file. But it's pretty easy for me to understand like how I need to slightly modify that to work with my file. And it would be the same in your code if you're asking GitHub Copilot to say, write this function for me to pull X data out of the database. It's going to write it mostly fine, but the table name might be wrong, right? Like I don't have that table in my database. You just made that up, right? But it's completely reasonable for me to go in and just update the table name, right? And that's how I've been using these tools in my own code and with a lot of success, right? Like unit testing, write a test that does this, or database queries, or other things like that, data visualizations. These things are very predictable things that have been done a million times. And I can have, whether it's Chat GPT or something like GitHub Copilot, I can have it generate basically the scaffold for me. And there might be a couple little things I need to change, but like I should not be writing that code. Like so many people have written this code over time. Like I just don't need to spend my time doing it again. Right.
But this is kind of like the idea that you're not writing binary either. At some stage, that code is somebody's written that. We know how it works. You're writing in whatever, it's converted to machine language and executed on the machine. Is there any kind of analogy we can use there?
Yeah, I think there is. I think that the people that have put in the work to do sort of things like compilers and garbage collection, right? Like those are things we used to do manually. Maybe some people still do. My physics colleagues back in academia are still writing Fortran code and all that good stuff. But yeah, I think that's something that we've automated. I think the difference here is that most of that is deterministic in terms of how it works. This sort of prediction of text or code is not deterministic, especially if you kind of, depending on how you parameterize, your output or the parameters that you use. So I think that's one thing to keep in mind, which is maybe a distinction is this is not some sort of deterministic rules based thing that's generating a SQL query based on what it knows about your database. It's just like predicting something that is probable, but could have these sort of hidden nuggets of badness in it, right? So I think that that's a good way to think about it is like this is very powerful and it will generate like really great things for you. But you should always assume that there could be hidden nuggets of badness.
I love the way you phrase that. I'm gonna remember this hidden nuggets of badness. Most people would say like your hidden nuggets of gold, and but no, not you. You went the other way. Let's go back to this idea of grounding the prompt. So we talked about that model that was built around scientific, a lot of scientific articles published different places, peer reviewed. So let's loosely call it the truth, and build a model on top of it, and then you could take pieces of that and paste it in and say, explain this to me. And the way I understood it was you are grounding the model here, saying this is the truth, this is a seed, this is the starting point, and then work out from there. And this was giving better results. So my question in terms of coding, in terms of interacting with databases, is it just a case of grounding them, giving them more access then? So let's say you had a SQL database, and instead of putting this very structured, rigid API in front of it, you just said, well, here is the database. These are the options. This is the format. This is an int. This is a float. This is text. They represent these things here. If we could describe them in the way and say, now that knowing that, do this for me.
I think that the difference here that we're really bringing out is like generation versus understanding. Understanding is like what we do that we understand how a problem works or what is factual or not. And we usually represent that in maybe in text or maybe in rules or in schemas of our database or whatever it might be. Generation is different, right? Like what we're talking about with these models is generation. So they can generate coherent output, but they don't understand anything, right? Like there's no way for this model to understand whether anything that it's outputting is grounded in reality outside of the data that it's been exposed to. So that's why I think this idea of grounding has been powerful because it kind of combines both things of understanding and generation in a really creative way. So like you said, instead of me prompting the model and just say like get this data out of my database and then it's going to write some code like it may be sort of reasonable code but it's not grounded in the reality of what your database actually looks like, right? But a different way that you could prompt that model is to say generate some code to pull data out of my database, pull it out of this table, and then you give maybe the schema of the table using a SQL function, and then you give some other information like this database is a Postgres database or something. So you're essentially injecting external knowledge into the prompt that you give the language model. And now it knows like if I generate like let's say my table name is users, if it generates code that queries a different table like my users, that doesn't make any sense. Like that's not coherent. So now you've combined an understanding element with a generation element to where it's going to generate something that's not guaranteed to be consistent, but definitely much more guaranteed to be consistent with that external knowledge that you've injected.
Yeah, thank you for that. That makes a lot of sense. And it's also this amazing segue over into this other idea I wanted to talk with you about, prompt engineering. So when I first heard prompt engineering, I honestly thought my first question was, like, how is this different from being very, very good at Googling things? I think you've explained a little bit of that, how it's different, because my understanding is now you're grounding things in reality. You're giving it a context, like within this context, please do that thing. At least that's my understanding now. Am I like a long way off from how you think about prompt engineering?
I think it's a good starting point to think about this sort of parallel with like Googling or searching something. I think how I've started more and more to form this idea in my own mind is by thinking about like how can I construct a prompt for this language model such that it reduces the sort of risk of the output as much as possible. And I can give an example of this. So like one thing you could do is question answer with one of these models, right? So what is the capital of Poland or something like that? Who is this politician or something like that? And you could just like one way to prompt would be to just ask that question. Okay, so that's version 0.1 prompt engineering. I could ask the question, but this has all the problems that we just talked about grounding, right? So okay, so now I do my next version of my prompt, which is somehow I want to have the question in there, but I also want to inject external knowledge. So maybe I do a semantic search of Wikipedia and find the Poland article or something like that, some paragraph out of that. And I now have a prompt, which is what people are maybe calling like a template or something like that, which is maybe the prompt says, answer this question, answer the following question based on the following context. Context, colon, then I insert my external knowledge, and then I say, question, colon, and then I insert the question from the user. Now I've got something grounded, which is much more likely to be factually consistent as long as I'm able to get that external knowledge injected in. But then I sort of have additional ways that I can engineer that prompt, right? It could be like, even if I inject the wrong knowledge into there, it could be I don't do my search good, right? And the answer is not actually in the injected knowledge. I could additionally engineer my prompt to say, answer the following question based on the following context, period. If the answer is not explicitly stated in the following context, respond with, sorry, I wasn't able to get the answer for you, period. And then you give that. So now you've kind of further controlled your output a bit more to say like, okay, well now I know if I get this response, my injection of information wasn't quite right. And this can go on and on, right? So it's almost like you have these prompts that are this is really how you tie these language models into your own application, right? So if I have a question answering application over some knowledge, that prompt is really a key element of it. And I want to engineer that prompt so that I get the behavior that I would expect and maybe avoid some behavior that I wouldn't like. Now, the kind of second level of this, I guess, so going from version 0 point something to version 1 point something is that you don't have to use a single prompt. So there's this concept of chaining or chain of thought or query decomposition or like all of these sorts of things where you would take some input and you would actually do a series of prompts to prompt the model to give you what you want. So maybe my question comes in and my first prompt determines it's more of a classification. Is this question a geopolitical question or is it an entertainment question? And then that kind of like builds this decision tree under the hood. And you have other prompts that deal with the entertainment stuff versus the geopolitical stuff. And you kind of chain these things together to, do a classification, get data from a database, answer the question, rephrase the question to make it sound better, find an image related to that question, and then you combine all of those things together to give this rich output. So that I think if people think about prompt engineering more like that as a sort of set of things that you can do versus like a single prompt, I think the richness can really come out in the responses.
Oh, that was a really great answer, and it gives me a lot of hope. I think a lot of people will be looking at this going, this is going to have an impact on my career. But this idea of grounding the model, saying within this context, given this knowledge, and then like working with it. This sounds silly to say, working with it, but that's the way I see it. Working with it to improve it in this gradual, hopefully, in a way that sort of narrows down and makes it more consistent, more like I can be more certain with the result that I'm going to get out the other end. It almost reminds me of generative adversarial networks in a way.
That's an interesting parallel where people have also used sort of multiple models to kind of work against each other or work with each other to perform a certain task. I think in this case, we have to view, and I like how you tie in like how this will affect people's jobs. Like you have to view this as a tool. Like ChatGPT is great, the interface is great. Like it that in itself can be a good tool for me to use, as an assistant. However, when you think about enterprise use cases and building your application on top of this technology, right? You have to think about this sort of like chaining and how you put these prompts together, and you have to think about the edge cases because it's much too risky from my perspective to say like, well, my application is a single page app and all I do is reach out to OpenAI once and get the response. That seems fairly risky to me in terms of like all the things that could happen with that. When really in application development, you want to think about like the needs of your users, and you want to think in terms of like you have been thinking over time in unit testing and other things like what is the happy path here? What is the not happy path or the negative path? And how do I construct the integrations to these AI models along that happy path and the negative path?
I guess the obvious question is now, so we can see how this could help us, right? We can see how this can amplify the work that we're already doing in the same way other technologies have done this in the past. They've amplified human effort. At least this is the way I see it. Who should be worried about this?
Good question. I think that I just mentioned some risk in terms of the way some people are using these systems. I very seldomly sort of have as my worry the sort of like sentience and singularity and like this is going to take over, nor do I really have the worry about these types of systems like ruining all of our jobs because I think that what has been demonstrated in the past is that these systems will change the way we work. And the people that latch onto them and are able to use them as part of their job will be the ones that move on to next things, right? Like with any technology, if you think about like there were people that adopted computer word processors above typewriters. And those people, yes, some pure typists lost their jobs, but people were still typing. They still had those jobs. There's still people that do data entry and all of that. It's just that the way that they do that is different. And in fact, there's more of those people now. So I think that I'm not worried about that. And we've already seen some spectacular fails where people rely on these systems a little bit too much or in a way that puts too much assumed understanding on these models and not enough kind of engineering thought and thinking about edge cases and how these systems might fail. That's more of what I think about in terms of risk and reliability versus kind of like automation and, robots killing me.
So in a previous conversation, you talked about radiologists. Would you mind like resurfacing that example for us, please?
Yeah, that's a really good one. I love this one. So there's a couple of articles about this, both academic and kind of popular articles. There was a lot of concern at some point because computer systems or computer vision systems are actually better at identifying certain diseases in medical imagery than human doctors are. So they're actually more accurate at that. So that begs the question, well, should we replace doctors with that's in this task with computers? The problem is that there's always edge cases, right? Like for the most common diseases, a computer will always outperform a human on these things because they've seen so many examples. But as we all know, there are very rare diseases. There are cases where, like, there's some special conditions for a certain patient. And doctors are really adept at knowing those and being aware of those, understanding when they should be thinking about those. And so what's been found over time is initially people thought, oh, radiologists, like their jobs are gone. But actually, the power comes when you combine the human radiologist with the computer vision system. And that produces a sort of hybrid environment where you actually get more efficiency, more thorough diagnoses from the combination of the two rather than either one or the other. And the fact is that there's more demand for radiologists now than there's ever been. But there's an increased demand for radiologists who know and are trained on how to use these AI systems paired with them. So if you're a radiologist who adopts the AI technology and learns how to use it well, you actually have a thriving job market, right? And there's more of a demand for those type of people than there's ever been.
Well, thank you very much for that. It's nice to sort of end on a positive note, I think, and I hope people listen to this and walk away thinking that the future is brighter. We will be able to use this will amplify what I'm already doing. This will help me be better at my job. That kind of thing. That's my hope of this episode, anyway. Just before we round things off here, I want to know: are you more excited and hopeful about the future of this, or less excited and hopeful about the future of this when you think about the way the world has responded to ChatGPT?
Yeah, I am very hopeful and I am very excited about this. I'm obviously biased probably to some degree because this is my day to day, but I'm excited by the fact that also the tooling is getting better around this and the interfaces are getting better around this, so that it's not just AI practitioners that are able to think about integrating these tools, but even in a sort of low code way, very many people are exploring integration into their applications, and I think that that's really cool. And that's brings a wider perspective and a wider diversity of eyes onto these problems, onto these systems. And I think the systems will continue to be made better because of that kind of wider diversity of people that are brought to the table.
That is a really good point. I think, all of us are better than any one of us. So, the more people we have, if we can get all of us looking at it, or more people looking at it, diverse set of people looking at it, hopefully it'll get better.
Yes, definitely. Yeah, and I appreciate you bringing this topic to the podcast, and yeah, would love to interact with people if they ever want to reach out.
Yeah. Well, thank you very much for your time. I really appreciate it. I've really enjoyed this conversation. I even enjoyed prepping for it. I was excited to ask some of these questions. I was excited to understand more about it.
Did you use ChatGPT to help generate some of your questions?
No, no, I didn't. I thought about it, but I'm kind of tired of seeing that on social media. I'm tired of like,
Yeah,
I asked ChatGPT this stupid question and it gave me this funny answer. Please give
yeah,
me some attention. So I, I didn't want to use it. Like these are questions I wanted to know the answer to, not
sure.
ChatGPT. And I'm grateful for your time. You said before people could reach out and interact with you. Where could they go to do that?
Yeah, yeah. So I would suggest people, if they go to changelog.com/community, we have a Slack channel for our podcast and for the Changelog network of podcasts. And myself and my co-host are there, and a bunch of other people that are interested in these topics and interested in other things related to the software in general and open source and infrastructure. So that's a great way to get plugged in both with myself and a wider community of people. You can also find out a little bit more about me at datadan.io and work at sil.org. And the product that I mentioned, Prediction Guard, is at predictionguard.com. So those are all ways to find me at various places across the interwebs.
Perfect. Thank you very much, Daniel. Really, really appreciate it.
Yeah, thank you so much. Hope to join you again when the next great AI thing is blowing our mind next year.
That'd be great. I look forward to it too. So I really hope you enjoyed that episode with Daniel Whitneck, data scientist and podcast host over at Practical AI. And I mentioned in the introduction that Daniel's been on the podcast before, and I'll put a link to that episode in the show notes of this episode that you're listening to now. I'll also try and link up other relevant episodes for you that might add some context to this discussion around AI. Okay, that's it for me. That's it for this week's episode of the Mapscaping Podcast. Thank you very much for tuning in all the way to the end. It's much appreciated. And I'll be back next week. I hope that you'll take the time to join me then.